Okay, and we are live again. I hope you're all having a great day. This is the final day at TestMu Let me know in the chat how's it going for you. If this is the first time you're tuning in, whether you've learned something interesting, I hope you all have. Uh, I'm joining in from New Delhi. Let me know if you are in and around from similar places or from wherever you're joining in from. We're just going to give it a few seconds and then we go live with the whole drill, because some people would still be shuffling from the previous sessions to this one. But yeah, I do see a lot of people showing up now. I think that's our cue to get this started. So good morning, good afternoon, and good evening, everyone. Hope you're having a great time so far at the conference. I'm Harshit Paul, Director of Product Marketing at TestMu AI, and I will be your host for this session on Build Your Own Benchmark, Why Agents Need Custom Evals, and How to Create Them. Before we get started, a few housekeeping items. This session is being recorded, so in case you need to drop off midway, you will get the whole recording over your registered email address. We also have a dedicated Q&A round at the end, so in case you have any questions while we're presenting, feel free to drop them in the chat box and we'll take them over. Do share your learnings from this session over LinkedIn or X. Do tag us and use the hashtag TestMuConf. With that said, agents are becoming the primary users of your software, which makes the leaderboard question, which model scores the higher? And usually the answer is always the wrong one. What makes, or rather what actually matters for these agents is whether they can complete the tasks or or whatever product that they are promising. Your workflows, your permissions, your edge cases, your SDK, and no public benchmark knows any of that. So you have to build your own most of the times. But how do you go about building your own agent? And that's what we're going to learn in this session. So join me in welcoming Haritha Sreedharan Nair, co-founder and CTO of Oqoqo, where she's building a platform that brings research-grade evals and benchmarking to individual teams. She spent a decade in AI/ML, previously led enterprise products at Windsurf, building agentic coding tools for Fortune 500 customers, and has publicly researched in reinforced learning as well. Haritha, welcome to TestMu Conference. The stage is yours.
Thanks, Harshit. Hey, everyone. Super excited to be speaking to you all today. And yeah, this is a topic that I've been spending quite a lot of time on, but I don't want to bore you with too much of an introduction. I think Harshit already did a good job. But my preface is that this is a very new topic. I think the space is evolving so quickly. So I definitely want to ask everyone to please add your questions in the chat window so that we can have a more open discussion towards the end of it. So let me share my screen. I hope this works. Yeah. So yeah, like Harshit said, we'll be talking about build your own benchmark, and there's a lot of content to cover. But to get started, I want to talk about the paradigm shift that we are happening. So the biggest shift in the past few years that we have seen is, of course, LLMs. But what has happened kind of adjoining that, especially with agents, is that who is using your product has sort of changed. So products are no longer used only through their UI. So earlier, you would have an individual user or a developer who is interacting with a documentation or an SDK or a product portal or a console and like doing actions, right? Of course, you would have some of us who are writing APIs to interact with some of these, but generally speaking, most of the usage came from a human writing a script or doing an action on a UI. In the past year or so, we have seen, for most people, this kind of change. It started with coding agents, and now it's spreading to all the co-work products that we are seeing around us. The primary interaction surface for a lot of us has become these agents, and you ask the agent to go do something. And how does that work? So imagine like earlier you would go to like Expedia's website and ask to like book a flight. Now you would ask an agent to go do that for you. And this is made possible through different interfaces that are built on top of your actual product. So you would have your docs, your SDKs, and your products still, but on top of that, you have MCP servers or CLIs or skills that the agents are accessing and then making that interaction on your behalf. And this is a huge shift, right? Because we are used to building products and doing tests on this side of the spectrum and not really on this side of the spectrum. And from a business perspective, the agent access is really showing up literally everywhere. This is like a very recent tweet, like from earlier this month, which is talking about how companies are reporting MCP usage in their earnings calls. And we have seen this firsthand when talking to customers that MCP usage is maybe like 20% of their total workflow today. And they expect this to grow and reach 50%, 60% over the next year, and it's growing exponentially. And this shows the same paradigm shift from a more business perspective of where the volume is coming, where users are coming from. But MCP is just one example. The general shift is agent-mediated work. And we have heard from our potential customers a lot of times when we have conversations and show the product, and at the end of the conversation, they're like, hey, but do you have an MCP? Because I can just ask Cloud Code to do all this and not have to learn how to use a new UI. And that is where the industry is today, where this kind of becomes a prerequisite for every single product. So like we said, your product has a new kind of user, but why is it different? So we are trying to take products built for humans and then trying to see if an agent can just use that through computer use. And there are a lot of reasons for why this is suboptimal. Some of them are how the agent behaves is quite different from how a human behaves. Agents tend to take error messages quite literally and actually try and understand them, unlike humans who would just try something else. Agents tend to read the tool name, unlike us who are just trying to follow an instruction. So for example, in our experiments we have seen that deprecated endpoints are often an area where agents get confused because they remember a specific endpoint and they try to hit that and it doesn't work and they don't really know where to go because the error message wasn't clear enough. For a user, this might have worked differently where they would reach out to support, they would try and raise a ticket or whatnot. But for an agent, they are going to try looping and trying to figure these things out, and it doesn't really work. So like Harshit said, the question is no longer which model is better, which is what a lot of us were dealing with in 2023 or 2024. Now we are talking about, can this agent in this harness with these given tools complete the work my users want to accomplish? So before I go into that, I just want to give some more context around how I have seen this evolve. And this is maybe where I introduce myself a little bit more. I was working in early 2023 at Microsoft where we were building copilots. And the way we built these agents were very different, right? Which it wasn't even called an agent. You were literally doing serial or parallel LLM calls based on what your user is putting into a chat window. And how did we do evals or tests in this era? We literally had a spreadsheet where we would write down all the prompts a user might put into the Copilot, and then take each prompt, put it into the Copilot window, see the answer that comes out, and put it back into the spreadsheet and see if it matched what was expected. That's it. And maybe use some semantic similarity to do that. We have come a long way from there. Then I went on to work at Windsurf for a while doing competitive strategy. And at this point, my job was to figure out how Windsurf compared to Cloud Code or Cursor when you give a certain task. So I again had to do evals. And in this scenario, I had to take, let's say, a front-end development task and give it to Windsurf. And then Windsurf would write some code. And now, okay, I have to revert that code so that I can give the same exact task to Cloud Code. But these agents became so much smarter by this time, which was mid-2025, that they would see the Git history inside. And they would see that, hey, the right answer was already here and it just got reverted. So let me just bring that back. So this means the contamination in the environment really impacted the ability to do evals. And I had to build my own hacky solutions to kind of do that. Fast forward to today, we have so many products out there which call themselves eval solutions. Our take is that none of them are really sufficient or none of them are thinking about the problem from first principles. And that's kind of the reason for thinking about why you need to build your own benchmark. But before going into that, I want to introduce some vocabulary. So we have talked about the shift that has happened. We'll talk a little bit about the space and the vocabulary around it. We'll talk about what makes today's evals not good enough. And then we'll cover kind of like the guidelines to building good evals. And maybe if we have time, I can also show you a quick demo of how we try and do evals and benchmarks for products. So going into the vocabulary, an eval is a test of one behavior or a single task. So if the task is write an email, and automating an email. So write an email to XYZ based on this data from CRM. That is one test of one behavior, and that's a unit eval. A benchmark is a repeatable suite of evals. So if you want to test the entire Google Calendar suite, you would have maybe 30 tasks or 30 evals, and the collection of those form kind of like a benchmark that you can repeatedly run. The equivalent to that in traditional testing is a regression suite. The rubric is what you use to grade. So this is basically the criteria you're saying, okay, it should have picked the email address from XYZ column in the CRM. It should have written the email in a certain way. All of that can be part of the rubric. And the fourth is the trajectory, which is exactly what the agent did and the steps it took and the decisions it made. The entire log that you would see is part of the trajectory. Now, the fifth and the most important thing is the task itself, kind of breaking that down. So the task is not just the prompt. It consists of what we call an instruction, which is the prompt, the initial state of the system. So imagine this is you're testing Stripe. The state of the system is all the transactions that have happened in the past or the current state where it's a new account. All of that count towards initial state. So this is an actual product interface. The available tools, docs, and files that the agent can interact with in that environment. So let's say you're trying to upload a bunch of data to your Stripe account, then the upload CSV is a document available to the agent to do that task. The fourth is the agent and the harness itself. The fifth is the rubric that we talked about. And all of this kind of leads us to the final state or output. Now, just to clarify, when I talk about agents, it could be a public harness like a Cloud Code or a Codex that's interacting with your product. Or it could also just be a harness or an agent that you have built, like a custom agent that you have built. In both cases, this is kind of a framework to think about evals. So when you talk to somebody and they say that they have evals, you need to ask which of these layers are they actually testing? Because I'll show you an example. This is from a very popular product. This is their evals literally in their GitHub. So if you look at the prompt, and this is not just one example, like literally all of their evals are kind of like this, where the prompt is, hey, we are doing XYZ. Today it does XYZ. I want you to tell me how to do something else. And this is basically a Q&A question that you could just send to Claude. You don't really need Claude Code for that. You won't be able to test an agent with a Q&A question because it's just asking a question. It's not making the agent do a tool call. It's not interacting with files. It's not interacting with the actual product surface. Most of our evals that are present today in the world kind of look like this. Extremely basic prompts. There are some criteria. You can see if they work or not, but most of the time, this is just a way to say that you have done evals, but rather than actually doing the evals. The second vocabulary is pass rate, and what does passing really mean? According to us and a lot of research in this space, a pass is not just dependent on the final outcome the agent produces, but also how it got there. So this includes the tool calls it made, the number of retries it took, how much latency did the surfaces have, what bypasses the agent made, and finally where it got. So the entire trajectory is kind of part of what is being evaluated. And this is super important. We did one experiment which was trying to figure out how well a particular vector database can do a certain thing. And then the eval passed. And then when we looked at the actual trajectory, we realized that the agent had decided that this vector database was too hard to work with and instead used SQLite and still did the same task. So when you look at the final output, it looks like everything worked, but the whole measurement was wrong. It was looking at the wrong product surface completely. So this shows how important it is to consider trajectories when doing evals. So this is the general vocabulary of what an eval means, a benchmark means, which is a collection of a bunch of these evals that help you test something. We spend a lot of our time thinking about how the agent experience is changing and how you can test your product against agents. But like I said, even if you're building your own custom agents, these same principles apply. You need to think about the trajectory. You need to think about having extremely comprehensive files and tool calls and being able to evaluate all of these things and not just an output. Now, We talked about benchmarks, but when I say benchmarks, what most people think of are public benchmarks, which is the SWE benches, the terminal bench, deep SWE, live code bench, all of these things. Um, the fact is, these benchmarks are great, but if you look at the fundamental question they're asking, it is, if I have to compare 10 different models, how do they rank amongst each other when you take a particular task, like a coding related task or an accounting related task? Does Gemini perform better than Claude Opus 5? Um, but for most of our day-to-day use cases, this is not, we already know what task we want to evaluate. We are not trying to figure out the best model for the job. Sometimes we might be, but again, like it comes down to you want to find the best model for your task and not for a general standardized test kind of task. The reason public benchmarks are helpful is that they create the comparability. They help you test the same task across many models. They allow you to kind of pressure model providers to create better models as new and new benchmarks come out. But like I said, you are still measuring the model and you're not measuring products that matter and you're handling. So they cannot really answer whether the agent can use your docs, your APIs, your auth, all of these things. A good leaderboard can still fail your users. So if the user is asking for setting a monitoring for failed payments, there would be auth in the middle, there would be permissions, there would be a schema that you have to deal with, billing state, email integration, so many things that are part of a complex ecosystem that's not reflective of how the benchmarks are run in kind of isolated environments where they don't have to deal with the complexity of the real world. So why are the evals people are writing today not good enough to solve for this problem? There are four major categories that I think of. Some of these we have kind of talked about, some of these are new. The first big one is that they're often too simple. We saw an example of that where the question, you're literally asking a question to an agent, which it can answer from its memory or from its training data. It's not even a serious way to test the agent's capability of finding information about you. So if you give the agent a task, which is literally writing down, okay, do these things. This is super simple. Your tutorials itself would have the solution to this task. You're not actually making it do anything new. But what's important is if you think about it, the way your user is using your product, you would state it as a job instead. So a teammate needs a reusable test payment setup for a demo. This is how a user would prompt. And there is no right answer for this that's already saved in the agent's training set. And this is where it actually turns into something that can be used as an eval and actually measure the agent's performance. The second failure mode is the exact opposite of this, where the eval becomes almost like a tutorial, where it lists the exact steps the agent has to do to go solve this problem. So at this point, you're not measuring the agent's capability to solve the problem, but you're measuring the agent's capability to follow instructions. And I'm not making this up. This is an example of skills bench, which is a benchmark meant to figure out how different models perform when they're given skills to operate with. And all of these instructions are part of the prompt that's given to the agent. Now, this is not bad for a public benchmark because it's a fair playing field. So you're giving literally the same instruction to every single model. So if the instruction is extremely detailed, it's just questioning the efficacy of the benchmark, but it's not unfair to the agents because all of them are getting the same instruction. But if you take a prompt like this and use for your internal evals, that's really, really bad because you're getting a false sense of confidence that the agent can do something, which it really cannot, because most of your users are not going to give this much of a detailed prompt to an agent. The third is when you test only against one or two agents, you tend to encode the quirks of a particular agent and forget the others. We saw this the most when, I guess in like early this year, we were experimenting a lot with skills. And we noticed that most companies were using Anthropic's guidelines for writing skills. And their skills would do really well in cloud code and give a lift. So that means if your average agent without a skill is performing at 60%, your agent with skill would perform at 65 or 70%. But it made other agents worse. So Codex would actually, using the skill, behave worse than its average. So if Codex on average is like giving 60% pass rate, it would reach 50 or 45 when the skill is provided. So this is a typical problem where everybody follows an instruction coming from one company, and that makes these assets not interoperable across different agents. So this means you need to test against multiple of them. And the last, like we said, is that just saying pass or fail really hides the product failure and where the thing went wrong. So even if something was passed, let's say it did 31 tool calls, it read the wrong docs, it used a deprecated endpoint, all of these are problem areas that you need to be aware of, which is not encompassed in like this one pass or fail that's coming out of the agent. So these are the major ways in which today's evals kind of break. We have also seen other cases, more nuanced cases, where the agent usually, when you see the transcript, at the end of the transcript, the agent would say, hey, I successfully completed the task. And then you send this to a judge, and the judge, which again is an LLM, says that, reads the transcript, sees this note, and says everything is great. So there's a lot of bias and other problems to solve. But from a product level, these are the four major patterns in which evals today are not sufficient. And these are evals from leading companies who have already invested time into building these. You also have a lot of companies who are only starting to think about this. Now we go into what this really means. Your product's benchmark is a measure of the user experience you have for agents. If the agent is only succeeding after so many retries, so many hacks, and so many workarounds, your product did not really pass the benchmark. And this is the essence we are trying to convey with why you need to build your own custom benchmarks. And the same applies for your own agents. If you're building your own agents and it took 6 different tool calls to get a simple answer for a user, that's not good. Just saying that the final answer was accurate doesn't mean that it was an actual pass and the agent was optimal enough. Now, what does a good eval mean? A good eval is just a simulation of real work in a small unit. So it's almost like a unit test. The first way to write good evals is to not build evals from your API surface. We saw this with MCPs, where when MCP came out, everybody took their entire API surface and kind of packaged it into MCP tools. The problem with this is that the API endpoints are called weird names, like let's say get user or get customer. And now there's an MCP tool called get user or get customer, which both semantically seem extremely similar to each other to an agent, which is interacting with it. And it doesn't know which one to pick. Maybe it needs to pick a third one, completely different one. And it doesn't know if it should pass a UUID or a different kind of an encoding to these two endpoints. So there's a lot of missing information when you just convert an API endpoint into an MCP tool. The same thing works for evals too. If you take an API endpoint or a more engineering task and create an eval, that's not going to be sufficient. The right way to do that is to think about the user job and what the user is trying to accomplish with your product, and write your eval or your prompt based on that. So a good instruction sounds like real users. So instead of saying, call this tool, get XYZ and calculate whatever, say something like, hey, we changed onboarding last week, check whether XYZ happened, leave a short summary. This is how a user prompts, and it needs to reflect that. So you need to think about what are the top 10, 15, 20 workflows your users are trying to do, and then write prompts based on that. And this doesn't mean that it needs to be ungradable or it's too subjective. You can still have good evals which are still natural sounding with technical details that helps you grade them. And then you need to focus on your rubrics. Your rubrics need to test, like we said, both the output and the trajectory. It needs to be clear enough, but it shouldn't be unfair. Like it shouldn't be asking for things that the agent was never even aware of and then testing on unfair expectations. So you need to include trajectories. Another thing that most people miss is running repeated evals. You need to run these over multiple trials to get statistical significance on the pass rate, because these are probabilistic systems we are dealing with. So they are not going to produce the same output every single time you run them. And the last thing is to classify the failures so that you know what to fix. So not everything is going to be a model failure. You need to be able to classify them into, okay, this is a hardness problem, this is missing context, this had an auth issue, this had unclear success criteria, so that you can then go back and fix them. This is how you take agent evals and then convert them into product feedback. So this tells you, okay, my docs were confusing to agents. Let me go and fix those. I have deprecated endpoints lying around in my documentation or in my Open API spec. I need to fix that. I need to improve the setup. I need to expose a certain primitive or clarify the error message. So this is how you get product action out of the eval signal that you're seeing when the agent interacts with the product. Now, there's a reason why companies are slow to adapt into this ecosystem and kind of think about their products this way. The biggest one is that they're afraid it'll cannibalize their existing product surface. So if you are somebody who is building like a scraping tool or an email provider tool, you don't want the agent to be the primary way your users are interacting with you, out of fear that people will stop coming to your platform altogether in the future. And this is a very real factor. And this is kind of the reason a lot of people are still building their own custom agents instead of relying on like public popular agents to interact with their MCPs. And we are yet to see how this kind of plays out, but the industry seems to be moving in a direction where it's kind of inevitable that people want to keep using their agents, and you need to give what the user wants than trying to force them to use a custom agent that you have built. So agents are still kind of treated as integrations and not really as users. And as the scale keeps growing and we see more, like, let's say, MCP usage, this is bound to change. And another reason is that there's no good benchmark infrastructure. Like, there's a lot of bottlenecks, there's a lot of problems in the space that we are also trying to solve. But the reality is there's no good way for you to measure with all the complexity that I mentioned and replicate something that is equivalent of your actual products to be able to run these tests. This is kind of the reason we built Oqoqo. We wanted to help people do evals, do benchmarks for their own specific use cases. I can perhaps show like a quick example. So these are some experiments we ran on Sentry, I believe, which I'm guessing is a familiar product for most people. This is Stripe. Okay, I can maybe choose WorkOS. So yeah, let's take a look at this one. So this is the instruction where you're asking users to zoom in a little bit. Okay, this is the prompt that you're sending to the agent, which is what you expect a user to ask the agent. You have a rubric, which explains what's the right answer, like we discussed. You have files, which is a mock repo in this case that you want the agent to work on. And you have machines, which kind of pre-installs the dependencies needed to run that piece of code. And then you create what we call an experiment, where you pick the tasks you want to run, you choose the agents you want to run them against. And we also seed the data into these environments so that there can be actual product interactions. You can bring your MCPs, you can bring your skills and see how it behaves. And then you trigger an experiment. I can go ahead and launch this. So all of these experiments are going to end up in isolated sandboxes where they can all run. And yeah, this is the one I just triggered. So yeah, there are 36 sandboxes created where all of these evaluations are running in parallel, trying to do the task that was given to the agent, using all these resources available to it, along with the MCPs and along with the product services that you have provided and the keys you have provided. I can quickly go to an older run so that I can show you the results and kind of talk about that. So this was Sentry, and we were trying to test some basic tasks in Sentry against Codex and Cloud Code and see how it behaves. So this is the eval output, but what we also find really interesting is to look at the steps, the number of steps the agent took, the number of tool calls it had to make, the frictions that it ran into, the token cost. This is really interesting because it looks like a query like this can be super, super slow when running even the frontier models and consume a lot of tokens. And this is something you can focus on and try and improve. The way we also cluster the problems the agents run into is by having a category called frictions itself, where all the problems that the agents faced are clustered into issues that a product owner can go back and fix. Yeah, agent implementation and test assumptions needed correction. Yeah, this was a big one that we found in Sentry, that a lot of the data that's coming from Sentry's docs and information tend to be super long, that it doesn't fit in the context window, so the agent ends up truncating it. So even without the knowledge of the engineering team, the agent is not able to read all the information that's being provided to it because of this truncation issue. And there's no way you would be able to identify this without running these evals and without running these experiments to understand how the agent is behaving against your product surface. And you get to go through the frictions, you get to also go into each one of these. Let's look at one of these and see the trajectory that the agent took, where it ran into a problem, understand the friction, see the output that it generated, see the evals that it had, and you can compare it against, like, let's say you want to figure out if codex versus, you want to do a codex versus cloud code thing, or you want to see which model gives better performance against your products. You can see over here that, okay, I was using Sentry MCP over here. How did the behavior really change? You can see all these MCP tool calls being made. So this is an interesting way to evaluate and understand how agents interact with your product and go deeper than kind of chickening out and being scared of like what the agents are doing underneath and only finding a workaround by just giving your full product to the agent to use, like where a computer uses something which is suboptimal for them. And yeah, let's go back to the slides. So this is the reason we built Oqoqo. So we run a lot of experiments. We try to figure out a lot of interesting stuff. We also do experiments like, hey, is open code with Opus 5 a better harness than cloud code with Opus 5? So there are a lot of experiments you can run once you have this kind of infrastructure available. You could also bring your own custom agents and do similar experiments where you're testing it, kind of stress testing it under all kinds of conditions and seeing how it behaves. The intent is to catch regressions before your users do and provide your users a great experience or a great agent experience. What I really hope you take away from this session is that agents are becoming a real product user, and the public benchmarks that we have are great, but they don't really measure your product's experience. Creating good evals need really intentional task design, designing rubrics, designing trajectory analysis, and a lot more. And custom benchmarks is the one thing you can do that can compound into having a product that you are confident can actually be used by agents, or having a really strong agent that you are 100% sure that your users can actually get value out of. So yeah, just to conclude, public benchmarks tell us how good agents are or models are, but custom benchmarks is what tells you the reality of how your product behaves. And that's the end of my talk, but it was really great talking to you all, and let me know whatever questions you have. We have, I believe, like 10-ish minutes left to chat more.
Great presentation. Thank you so much for detailing that in such great depth. We do have a lot of questions on the chat. Let's start taking some of them. Let's take this one. So how can you best test an agent's ability to recover from tool failures or unexpected API errors?
Great. Yeah. So the best thing you can do is analyze the trajectory. You can see in detail, most of the agents still provide their reasoning traces to you, and you can see where they got stuck and how they try to recover from there. And you can, one thing we do is provide, in Oqoqo's case, we provide it through an MCP. So you can actually ask an agent to analyze the trajectory and tell you how it recovered from there. So you don't have to do the grunt work of like building analytics on top of that. And instead, you can use an agent to look at all these trajectories. The important part is collecting these traces and making sure you have access to that across different agents.
Great. And speaking of trajectory, I'm sure you touched this upon the session as well, but what trajectory details such as tool calls, reasonings, step timings are essential for eval versus unused extra data?
Yeah, it's a gold mine of information, the trajectories. I think the important thing first is, like I showed you in the graph, to bucketize them into phases the agent is going through. So there's a lot of fun stuff you can find this way. So for example, we found that Codex tends to spend a lot of time thinking and planning and then finally writes an answer, whereas Cloud Code is more like, let me try this, and then, oh, that didn't work, let me go back, let me try something again. So there's like a lot of interesting behavioral patterns you notice. So first thing is to kind of chart down how it's behaving and what the process is for the agent to think. And then you can take out tool calls are really important. The token consumption per tool call is really important. The step duration, so time and token both are really interesting and like kind of connects back to your dollar per task value that your users are having to spend. I think there's a lot of verbosity that you can kind of skip and ignore and just take a look at the tools and the tool outputs, and that tells you a lot. And then the immediate response after the tool is also important because that tells you if the tool was helpful or if it was misleading when the agent was trying to do something.
Got it. And speaking of tool call failures, let's also address the elephant in the room, flaky test, right? So how do you handle flaky tool call failures or 3P API rate limits during long benchmarking suites, the new ones?
I love how smooth the transitions are, Harshit. Thank you. Yeah, this is a great question. I think the only solution is to do this recurringly and not stop at one trial so that you have multiple trials across which you can see the eval output. Rate limits are really serious and a problem. We have built a lot of infrastructure to identify 429s and then pause the eval process there so that we can recover as the slots get free. So you kind of need to build infra to do that, or you need to have like multiple iterations happening. The important thing is to not make the 429s worse, because the problem with running benchmarks is that you are triggering so much in parallel that you could be hitting an exhausted endpoint over and over again and making it worse and having like cascaded failures. The important part is to be able to identify the 429s or the failures and take a pause and identify when you can retry again and hold the infrastructure to be able to do that. That's, I would say, the trickiest part. But one solution is, of course, to have multiple trials so that you are not relying on a flaky test to make a judgment on what went wrong.
Got it. And if, let's say for small teams, if a solo practitioner or a part of small team is working on to this agent, what is the best starting point for building one's own benchmarks?
Yeah, I think the hardest part, even for like larger companies, that I think is applicable to everyone, is writing down those use cases you actually want to test and having a good, like, something that maps your user flows and identifies, okay, these are the 10 things that no matter what my users should be able to accomplish, and this is what success looks like for them. I think the reality is most people are just lazy to do that and they don't have good eval sets for that one reason. Once you do that, everything else, like, you have infrastructure to help you. Like, you can come to Oqoqo, we have like a free tool. It's like you get a bunch of free runs and play around with it. You can build your own tools. We use Harbor framework underneath, if you have heard of it. You can use Harbor to build your own like mini version of this and run it. But the hardest part is just sitting and doing that. A lot of times we get asks from people like, can you help us create the eval set? And we're like, we can try, but only you understand your users really well. And that's kind of the hard part of the problem that somebody with the product mind and like ownership needs to take up.
Right. And how frequently how frequently must custom benchmarks be updated as product evolve? What is the maintenance cost of preventing staleness?
Yeah, this is really important. Honestly, I think we are so early in this whole space that nobody has even started to like have their own benchmarks, that staleness has not even come up yet. But I would assume that there's a lot of work happening around self-maintaining documentation. I would kind of imagine like we would have self-maintaining benchmarks, which can kind of flag to you when a new release happens that this certain thing is not valid anymore, and we can like go and update it. But yeah, I would say it's like quite early to think about staleness and maintenance, but I'm sure it would come up like maybe a year from now. I personally think most companies are 5 months away from having their own benchmarks and having this kind of test suite. They're still figuring out a lot of things, including creating those eval sets. So we are a little bit further away from that, but would be definitely important.
Awesome. And how do you set realistic permission boundaries in eval environments without exposing real credentials or customer data?
Yeah, test accounts, like have a bunch of test accounts. So most of the tests we do are not mocks. We are not mocking anything because you kind of miss the nuance of the real product if you're trying to give mock answers. But this also means you need to give access to a real account. So have test accounts. The hard part is again having dummy data in there, which is representative of an actual user behavior. That's again another space where you need to spend a bunch of time. We are trying to see how we can help companies do that. But once you are done, test against that particular account. We are also investing into figuring out how we can not just seed the data but also clean up the data after each run, so that you can repeatedly run these evals without having to worry about like the run failing just because that data already exists. So there's a lot more problems to figure out. But to get started, like you can write read-only test cases which focus on the read operations and not the write operations, so that there's not a lot of conflicts in the data sets. You can have test accounts fully isolated just for this purpose, filled with similar-ish data to what your customers would be operating with.
Awesome. I love the energy on the question. So many different questions and the way you are answering all of them. But we do have, we are running short on time a bit. So I'm going to skip past a lot of these and maybe just take a couple more. How do you weigh conflicting signals, such as an agent completing a task inefficiently versus failing with better reasoning?
Huh, interesting. Task inefficiently versus failing with better reasoning. I'm not sure if I fully understand it, but I think the interesting part is to not treat, honestly, most of the time I ignore the eval pass or fail and I go straight to frictions. Because that's what I care the most about, like where it really struggled. And the inefficiencies are often a result of the frictions itself. Even failing with better reasoning, like to me, like it doesn't really matter what it did, but if like let's think about both the cases. Let's think about the case where you're testing a product against an agent. I care about where the product was the problem. I care about when I ended up causing most of the token consumption, and that's something I need to fix. If you're testing your own agent, then I think both of these are important. But again, you get to look at the frictions and identify what was the problem and what really caused the failure. And another thing we try to figure out is mark each friction as kind of unrecovered versus recovering. So the recovering frictions are the ones from which the agent is able to figure out a solution. Still, the unrecovering ones are the worst because they failed as a consequence of this friction happening. And that would probably be like P0 for figuring out this problem.
Got it. And one last question, call it uh, and then we call it curtains. How do we test whether an agent selected the correct tool or API?
Yeah, rubrics. So if you know what the right tool or API is, add it as a rubric and see if it actually used it or not. We also do something called a run profile, which is basically profiling the run in terms of the product surfaces it touched. So we call out what MCP was used, what API endpoints were called, and so on, so that there's a better visualization, honestly, and you can see what was getting invoked. For example, a lot of times you've seen some skills are completely useless and are never touched by a lot of the agents. So you can probably deprecate it and things would still work. Something similar applies for APIs too. Like you might have certain APIs which are getting a lot of usage and some which none of the agents are touching. That's a good way. The second way, honestly, is to again use our MCP or like any product MCP to let the agent create custom visualizations for you, and that saves you a ton of time and you get a lot of insights on what was the right tools or like what was called versus what was not. And yeah, really gives you insights that nobody else can know what you want, and like you get what you really want to understand from the product.
Awesome. Again, now that has to be a wrap. Thank you so much for that insightful session, Haritha, and laying down a complete path to building custom benchmarks for agent evals. Oqoqo looks super interesting. I'm sure a lot of us are going to deep dive on the platform as we design real world AI agent tasks. Thanks to everyone who joined us. Do share your learnings and experience over LinkedIn, X. Tag us, use hashtag TestMuConf, and you will stand a chance to win prizes up to $1,000. and the rest of the community also gets to pick up from your learnings. And this is the final day of the TestMu Conf. We still have some amazing sessions lined up before we get to the closing note. So stay tuned, look over the agenda. Happy learning and happy testing. Thank you so much.
Thanks, everyone.